PCHers. This is our only new lesson this week, 12.5, Planes in Space. Pigs in space. So this is going to be about coming up with the equation of a the equation of a plane in space. And in general, it has this form for an equation. It's similar to the standard form for the equation of a line, which would have been, or which is that. So we have an extra dimension since it is a plane. The constant d in this case is kind of determine where the plane is. So you can have the same coefficients a, b, and c with a different d. It just means you have a plane that is parallel someplace else. Same way as c is going to be in the equation of a line is related to the slope. You might have a line with the same slope, but it'll have a different y-intercept, and c would be related to that. Okay, so let's look at how this works. I don't know if you remember, a couple videos ago, I talked about the word perpendicular is going to have many different variations. So remember, you can have orthogonal vectors, are two vectors that are perpendicular. Well, now we have something called a normal vector. And what is a normal vector? It's a vector that is perpendicular to a plane. So here you would have a plane. And if I have a vector coming off of that plane, it would be perpendicular to that plane. That would be a normal vector, which we tend to denote with little n for normal. And notice that it has the same coefficients as the equation of the plane, which is very interesting. So that ABC is going to be a shared coefficient, which is going to make this really easy. So to find the equation of a plane, given a point on the plane, so given like a P naught or something, a P, an initial point, and a vector perpendicular to the plane, so we are given a point and a vector perpendicular, we can use this to find the coefficients A, B, and C, which are the same as the coefficients of your normal vector. All right, let's go through this. So in this case, we are given the normal vector, and we are given a point on the plane. And so we were given basically this vector. That's our perpendicular vector, our normal vector. Here's the point on the plane. And again, that just looks like a vector and a point, but we happen to know, since it's a normal vector, we happen to know it's perpendicular to that plane. So we start off with the equation of the plane, which is ax plus by plus cz equals some constant d. We happen to know, since they gave us the normal vector, we happen to know that a equals 11 and b equals 2 and c equals 13. We know that because those are the ABC coefficients in the normal vector. It's like, woohoo, okay, we're almost there. All we need to do is solve for d. That is where knowing a particular point comes into play. That is a particular xyz that sits on the plane, so it satisfies the equation of the plane. So we just come over here and we plug in 3 for x and 5 for y and 7 for z. And when we work that out, it comes out to be 134. And so what we can then do is put it all together. So the equation of our plane is 11x plus 2y plus 13z equals 134. So something to remember, especially if you're looking at the book solutions, is that if I were to have a normal vector, realize I could also have the opposite n, so everything could have the opposite sign. it would still be perpendicular to the plane. You could also have a common multiple. So sometimes if like 11, 2, and 13 were all, say, even numbers or divisible by a common factor, I could reduce that equation. It would be equivalent because it would just differ by a scalar. All right, so keep that in mind when you're checking your answers in the book. All right, now this next one is going to be really difficult. So given the equation of a plane, here it is. They give you the equation of the plane. We want to find the normal vector to that plane. Well, remember, A, B, and C are the same, so the normal vector is 4, 5, -2. They share the same A, B, C. That's it. It's so easy that people forget it. So remember, the equation of the plane and the coefficients are also what goes into the normal vector to that plane. And like I said before, any multiple, so 8, 10, -4, would also be normal to that plane, or if I could reduce it. All right, now let's do one. So let's look at this. What would the dot product of a normal vector and any vector on the plane be? So that's saying that if I had a plane, here's my normal vector, so that's perpendicular, and I have another vector on the plane, what do I know about the dot product? Well, remember the dot product by definition, good review problem, is the magnitude of A times the magnitude of B times the cosine of the angle between them. And since cosine of 90 is 0, those two vectors would have a dot product of 0. That's going to be important later on. And then what do you think are the characteristics of parallel planes? Well, it's kind of like having parallel lines where you know they have the same slope, but they are in a different place. So parallel planes, they are going to share the same ABC. They're going to share the same normal vector, in other words, but D will differ. Okay, because if I have another plane down here that's parallel to that plane, well, that vector, this vector here, is still going to be perpendicular to that plane as well. Okay, so let's now put this all together. So we have the equation of a plane is perpendicular to a particular segment which contains the points A and B, and it passes through the midpoint of that segment. The plane passes through the midpoint. All right, so let's give ourselves a little picture of this. I'm going to use my 3D drawing estimation skills. So I'm going to go out 6, and I'm just estimating here. 6, back 4, up 2. That means I'm going to put A right here. Okay, that was nice. And again, it's just a point. Then B. B means I went -4 over 2, up 4. I'm going to put B over here. All right, so here's A and B. Here is a line. Whoops, hello, lost my pencil. Here's the line that connects A and B. So first thing we want to do is find the midpoint between A and B, because this segment is perpendicular to the plane, which contains the point M. So, yeah, my 3D drawing skills are not that great. I guess this should be dot, dot, dot there, because it's going, I don't know, it's going through, and then it dot, dot, dots, and comes out the other side. Yeah, okay, you can deal. Okay, so what are we going to do? Well, let's first find the midpoint of AB. On some other problems, you might have to actually find, 70% of the way or 25% of the way or something. But this time we can just do a midpoint, which means you're averaging your x, y, z values. So I have 6 minus 4 divided by 2. I've got -4 plus 2 divided by 2. You add and then divide by 2. And then we have 2 plus 4 divided by 2. That gives me a midpoint of 1, negative 1, 3, right? 2 divided by 2, negative 2 divided by 2, 6 divided by 2. There we go. So that's going to be my midpoint. Awesome. So we have a point. Well, this kind of goes back. We need a normal vector. So what would my normal vector be? My normal vector is going to be the vector, the displacement vector, that goes from A to B, or from B to A. Does it matter? I don't really think so. Just a matter of whether you get a positive or negative. So remember, this is the backwards B minus A. So your normal vector, it's going to be, so if it's B minus A, negative 4 minus 6, and then 2 minus a negative 4, so 2 plus 4, and then 4 minus 2. All right, awesome. I have a normal vector. I have a point on the plane. So the equation of my plane, remember, AX plus BY plus CZ equals D, where we know A is negative 10, B is going to be 6, C is going to be 2, because that's the vector, the normal vector, because they told us that segment is perpendicular to the plane. Now, I need that point, so I take the point and I plug in. For X, we have 1. For Y, we have negative 1. For Z, we have 3. And when you put that all together, negative 10 minus 6, negative 16 plus 6 is a negative 10. So voila, the equation of our plane is going to be negative 10x plus 6y plus 2z equals a negative 10. And that's it. All right, I hope that was good. Nice and short, one pager.